In just 2 days, Wednesday, August 12th, 2026, the only total solar eclipse of the year will cross the northern hemisphere. Right now, millions of tourists and research scientists are mobilizing across the globe to put themselves directly in its path. Eclipses themselves aren't mathematically rare. On a global scale, the Earth experiences a total solar eclipse roughly once every 18 months. But this chart shows the difference between global frequency and local scarcity. While the planet gets an eclipse every year and a half, any one specific location on Earth waits an average of 300 to 400 years for a direct hit. People understand this math. Tourists are spending thousands of dollars per person on specialized travel packages, and hotels across Iceland have been completely sold out for months. The massive human rush driving this event is fueled by a simple reality. The value of the 2026 eclipse lies entirely in its extreme geographic scarcity. Looking at this map of the 2026 trajectory, you can trace the exact footprint of the moon's shadow as it sweeps across the northern hemisphere. The path of complete darkness makes landfall first over the remote, icy coastal terrain of Greenland. From there, the shadow races over Iceland. Because it offers multiple cities directly inside the path and the clearest anticipated skies, this specific landscape has become the absolute epicenter for viewing. Iceland hasn't experienced a total eclipse since 1905, and it won't see another one for over 50 years. Your exact coordinates on the map dictate exactly what you get to experience. When the moon slides in front of the sun, the shadow it casts on Earth is divided into two distinct zones: a deep, narrow center of complete darkness called Totality, and a much wider, lighter outer edge. This map illustrates what that outer edge looks like for North America. Viewers outside the direct path will see a partial eclipse. Canada will experience 80 to 90% coverage, while the contiguous United States sees between 40 and 85%, depending on latitude. If you are standing anywhere in that partial outer shadow, looking up is physically dangerous. The sun's remaining visible light is intense enough to cause permanent damage to your retinas. To safely observe the partial phases, you must wear specialized viewers. Standard sunglasses offer no protection. You need lenses strictly certified to the ISO 12312-2 safety standard. Where you stand on Wednesday dictates both the physical risk to your eyes and the strict safety rules you must follow to watch the sky. But if you are positioned perfectly inside the deep center of the shadow, the rules completely change. For a narrow window of 2 to 4 minutes, the moon totally adheres the sun, and you can safely take those glasses off. The physical changes on the ground are immediate. Air temperature plunges 10 to 15 degrees, and daylight drops rapidly into an eerie midday twilight. Above, stars suddenly become visible in the afternoon. Because this eclipse aligns perfectly with the peak of the Perseid meteor shower, observers might see bright meteors streaking past the darkened sun. Totality is a complete multi-sensory disruption of our most basic expectations of daytime reality. The true centerpiece appears directly overhead. Surrounding the black disk of the moon is a brilliant white halo known as the corona. 99% of the time, this sprawling outer atmosphere is hidden, washed out by the sun's overwhelming glare. That brief blockage of glare triggers a massive scientific mobilization. NASA and research universities deploy sensitive telescopes directly into the shadow's path to measure solar winds and observe the sun's inner atmosphere, the chromosphere, without light interference. For astrophysicists, the path of totality is a highly anticipated, naturally occurring laboratory that grants them access to data they cannot gather any other way. Just as quickly as it begins, the darkness fractures. The instant a sliver of direct sunlight returns, safety glasses must immediately go back on, and the shadow continues its sweep out over the ocean. The physical event ends in minutes, but the data gathered takes years to unpack. Ancient peoples used past eclipses to build complex calendars and map the heavens. During a historic total solar eclipse in 1919, astronomers were able to observe distant starlight bending around the obscured sun. That observation provided the exact mathematical proof needed to validate Albert Einstein's theory of relativity. Fleeting moments of sudden darkness frequently provide the exact conditions necessary to illuminate our greatest scientific breakthroughs. Today, the data helps us predict severe space weather, the intense solar flares that directly threaten our climate, satellite networks, and global communication grids. We live in an era of deep space probes and advanced digital networks. Yet, to gather all this essential data, we still rely entirely on the mechanical simplicity of a moon sliding perfectly in front of a star. That is the ultimate draw of August 12, 2026. It fuels a massive localized tourism economy while simultaneously uniting international researchers in a focused scientific pursuit. It is a stark reminder that despite all our technological advancements, we are still subject to the awe-inspiring mathematical clockwork of the cosmos.